When we're talking about data breaches, we use words like, devastating, embarrassing, catastrophic, maybe sometimes avoidable. Last week, there was a critical data breach where all of these adjectives really applied, and that was a breach of an app called T. My name is Johannes Ulrich, but today you will not hear from me. You'll hear from an actual expert, Brandon Evans. Brandon is one of our star instructors in the cloud curriculum, a senior instructor with SANS, and he'll focus on one particular aspect here, and that's the use of Firebase. Very commonly used with mobile apps, and he'll explain a little bit more what happened, how to avoid issues like this in your own applications, and also how to discover problems like this before they lead to a breach like we had in T.
Thank you for having me today. I'm looking forward to talking about the T breaches, how this has taken up a lot of the airspace recently. I'm going to talk to you a little bit about some of the misinformation surrounding these breaches, as well as the true root cause of the problem and how you can prevent your organization from suffering the same fate. So let's first and foremost talk about T and the T breaches. Now, before these breaches, I was not aware of the T app. That being said, I'm not the target audience, as I'm male and I am not in the dating market. But T was designed to help women feel safer on dates. The idea was that you could use this application to perform background checks on potential dates and perform reviews on dates that you've had in the past so that you can provide green flags or red flags to potential suitors. Now, at least initially, in order to access the T app, you would have to upload your photo identification in order to prove to T that you were, in fact, a woman. And this, as you can imagine, was a very serious treasure trove of information for the hackers. At the same time, a lot of people criticized the application for doxing men because fundamentally, the T application leans into the idea of spilling the tea, which is slang for sharing gossip. So a lot of men, a lot of disenfranchised or men that felt disenfranchised thought, hey, if these people are going to gossip about us and say bad things about us, we're going to dox them. And this made T a very good target for far-right hacktivists, which is what got 4chan, the anonymous message board, into the mix. So as a result, there were multiple hacks that happened. The first one that was reported said that 13,000 user photos and IDs were exposed, although Business Insider stated that another 59,000 images were exposed within the app. The 13,000 were simply for verification purposes, the selfies and the photo IDs. And while there hasn't been a whole lot disclosed about the second breach, it was even worse in that it involved private messages between these users, and a lot of very sensitive conversations were happening there. If I had to guess, I would argue that these breaches were caused by the same vulnerability, and really people just didn't realize how big of a deal it was until the second breach occurred. Now, the impact of this was tremendous. As you can imagine, if all of these users' photo identifications are compromised, that also means that all of their addresses are compromised. So this is an application, a Google map, that allegedly shows where all of the users of T reside, which is very terrifying for their privacy. And things got even worse. A lot of these people that were involved with this hack ended up creating an application that basically was a hot or not application where they would review the looks of users who did the photo verification on the T app. And I don't call this application sexist lightly. If you do not know what the term foid is, I would not bother going down that rabbit hole, but many organizations consider it to be hate speech. So a lot of people have been talking about vibe coding and how vibe coding is related to this breach. Now, what is vibe coding? The idea behind vibe coding is that instead of getting a computer science degree, getting formal training in programming, or really just learning programming at all, we can offload all of this work to Gen AI. We can tell our Gen AI platforms what we want, and it can then write our code for us. So this is an example GIF showing what vibe coding looks like from this Medium article I found from this group called Yourware. And honestly, this example is very tame. They're simply saying, how can I make this application better? And they're asking a very technical question related how they can make the application code better. Whereas many of the examples I've seen in the past are where people who have no programming experience whatsoever will create an entire application from scratch using a handful of queries. Now, vibe coding has gotten a lot of negative attention recently from the security community. A lot of people have been making fun of people who've been creating applications using vibe coding. Here's one of the examples where someone was telling programmers that you have to basically change your job because Gen AI is going to replace all of your hard work. And then just a few days later, this user says, hey, my website has been destroyed as a result of me not putting any security protections in there. And Cursor, the vibe coding solution in this question, did not provide any of those security controls either. Now, this could be a little bit of fun for security professionals. It's definitely a lot of fun for developers. I come from a programming background, and although I don't really trust vibe coding, I also don't really want vibe coding to succeed from a selfish perspective because my skill set would be a lot less valuable if we could simply have ChatGPT or Cursor or a GitHub Copilot just replace the kind of work that I do. But I am very skeptical about it because Gen AI is based off of large data sets, basically the entire internet, and there's a lot of bad code that's on the internet. We make fun of people for copying and pasting code from Stack Overflow to their applications. This is the same concept, but with zero accountability because there are no users to answer to any of the issues that come about from copying and pasting the code. But also, it's just everything. There's no vetting about what data was good and what data was bad that helped generate the code. So I'm skeptical of vibe coding. I'm not a fan of it. I kind of hope vibe coding goes away for both security reasons and for selfish reasons. But everybody blamed vibe coding on this breach. So what was vibe coding's impact on the breach? Nothing. Literally nothing. I could not find a single article that provided any evidence that this application or part of the application was built using generative AI, let alone that the breach was caused as a result of vibe coding. So how did this happen? Why is everybody talking about how vibe coding caused this issue when there is no evidence on the subject? Well, vibe coding is an easy scapegoat. I just mentioned to you how a lot of people have been piling on vibe coders, just like people are piling onto Gen AI artists because they just produce arguably, generally speaking, inferior products and are trying to make certain types of careers obsolete. I mentioned that I kind of feel this way, but a lot of people feel this way. And there are so many examples of vibe-coded apps getting hacked with relative ease in 2025. And considering that the techniques used in the T-breach were so trivial, well, as a result, a lot of people assumed that this was vibe-coded. But in order for that to logically make sense, you would have to argue that all bad applications are vibe-coded. That's the only way that you can draw this conclusion in a definitive way. And as Johannes and I were discussing before we planned this webcast, developers can do stupid things without AI. Very, very big mistakes can be made, even if you're writing the code by hand. Not only is there no evidence that vibe coding was at fault, there's a lot of evidence that points in the opposite direction. First of all, vibe coding was a term coined in early 2025. There were a lot of people generating code using generative AI prior to 2025, but this was not a major fad. This was not a common thing that people did, certainly not at the scale of what you can do today with code generators that just build entire applications based on a query. Now, T launched in February 2023. And while Gen AI was a big deal in early 2023, it was just getting started. Certainly was not being used to build full applications in early 2023. Additionally, the database that was compromised was created in 2023 and probably decommissioned to some extent in 2023 because the main data that was compromised, these photo IDs, according to T, they did not require photo IDs as of 2024. Somewhere in 2023, they stopped requiring users to upload these IDs. And they claim to have stopped using the database altogether in February of 2024. So all of the mistakes were presumably made well before vibe coding was even in the cultural zeitgeist. Like it's not something people were talking about, and yet everybody's assuming that vibe coding was at fault. And this is very frustrating and somewhat personal to me because the security community is using this as a way of ignoring the real issue. Whether they're doing this intentionally or not, they're probably not doing it intentionally. They are using vibe coding and the fad of piling onto vibe coding to ignore the real issue that I've been screaming about for years and years and years, and that is Firebase. So let's talk a little bit about Firebase and how it was involved in this breach and how, frankly, it's been involved in a lot of security incidents that people have simply ignored. So Firebase is not a new service, not at all. It was a service that was created out of a company that was existing back in 2012. There were these people developing a real-time application for a chat service. And for those who are not developers, making real-time applications is so hard. You have to create a WebSocket server. You got to create WebSocket clients. You have to create an entire message scheme. You have to update the UI whenever a message comes through. It's complicated. I've done it before. It's not easy. It's certainly not something that you want to do as a part of your first application. But there are a lot of applications that need to update data in real time without refreshing the page. So these folks that worked on this real-time group chat service said, hey, what if we took the technology that we've created to enable this chat service and made it generally usable to build real-time applications of all sorts of functionality? And that is how the Firebase real-time database came about. And from a user perspective, Firebase is really nice. It's so easy to get up and running with Firebase and develop a product that mostly works. But it's also very scary from a security perspective. Their goal is to make servers optional, such that, and this is a direct quote from their original marketing website, data stored in Firebase is directly accessible from JavaScript on the client. That means that Firebase databases are publicly accessible by design and that there is no intermediary application server. Historically, you'd have your client, you'd have your database, and in between, you'd have your application server that is going to manage requests and say, hey, this request was legitimate. I'm going to allow it to go through. This request was not. I'm going to block it. And Firebase eliminates that intermediary application server, which is why authentication and authorization is such a large issue related to Firebase databases. And that is largely what happened with T, is they made a very significant mistake related to authentication and authorization. One of the reasons why Firebase is so popular today is that it was acquired by Google just 2 years later in 2014. This acquisition already happened over a decade ago. And at that point, Firebase had become its own cloud platform where they had multiple different services that they developed, not just the database, but also a hosting platform and an authentication platform in order to support authorization to their databases and web pages. So Firebase is still very much alive and well today, even though it was acquired by Google back in 2014. So why should you care about Firebase beyond the T breach? Well, it's largely because it is extremely popular. You may not have heard about it, but your developers have. At the time of the acquisition, there were 100,000 developer accounts that were provisioned. And many years later, at least according to Firebase's marketing, over 3 million developers from startups to enterprises use Firebase to reach and engage billions of users. That's according to a blog post of theirs in 2022. And the number seems to just keep rising over and over again. Another reason why it matters is that if you use the Google Cloud Platform, its security is impacted by Firebase's security. And if you're not using Google Cloud and you're using Firebase, surprise, you're actually using Google Cloud to a certain extent. It's also required for certain Google integrations. Integrating Google Analytics and Google Ad Services on a mobile device, you need to use Firebase. It's also by far the most popular way of sending push notifications to Android devices. It's very popular for modern single-page applications and mobile apps. It's also being taught to the next generation of developers. I taught at the Vanderbilt University Coding Bootcamp back in 2019 before I got involved with SANS. And this was a very interesting program where we had to teach people with no IT background whatsoever how to become full stack application developers in 24 weeks. Learning how to code in 24 weeks is very, very hard. Learning how to write secure code in 24 weeks is impossible. We didn't even try. We gave them tools and to some extent shortcuts in order to enable them to make workable applications with the hopes that when they entered the workforce, they would be mentored by senior engineers that can help them understand how to build these applications securely. Whether or not the senior developers are actually helping out in this regard, it's hard to tell whether or not that's been a success. But there are a lot of developers that graduated that program that are in industry. But it's not just people coming from non-traditional backgrounds. It's also university students. I had the pleasure of judging a hackathon, which was also hosted at Vanderbilt University. And there were a bunch of really smart college kids, I guess I could call them kids, that were participating in this event. And this event was sponsored by Google. So one of the products they were encouraged to use was Firebase. And we had some students from Vanderbilt. We had some students from Georgia Tech, very reputable organizations, very reputable educational organizations, very reputable universities. And I judged one of the applications built by a team from Georgia Tech, and it was beautiful. Like, it was a great application. It had a real use case, it worked, and they built this in 24 hours. So as a security-minded judge, I said, hey, can I look at how you built this? And they showed me the Firebase platform and how they configured it, and their Firebase database was wide open, very much in the way that T's database was wide open. Now, I'm not upset that these folks did not implement security for a hackathon. You know, a hackathon is to build something quick and dirty. You're not going to really go through security review and think about security in such a period of time. However, what was scary is that they were not aware of these settings at all. They were able to ignore these settings without any friction whatsoever, and they were able to build this application. This happens in the real world as well. A lot of people hack together projects for prototyping purposes, and then once they are shipped to production, whether or not the developers want it or not, it is so hard to get rid of because Firebase is, simply put, the stickiest technology I've ever worked with in my entire life. Getting rid of Firebase does not take days, it does not take weeks, it does not take months. It takes quarters or years. I have worked with organizations that wanted to get rid of Firebase, not because of security reasons, but because of performance reasons. And they had that ticket on their task board for years and years and years. And there's not a whole lot of alternatives to Firebase. The only alternative that I'm aware of is this open source tool called Supabase, Supabase. And that's just a open source clone of Firebase, perhaps something that is equally insecure. I'm not really sure. I haven't played around with it enough to know if it's any better or worse. But if it's a clone of Firebase, it's going to have similar problems. Now, what's kind of interesting about this is that when Google acquired Firebase, the plan seemed to be that they would acquire this platform and merge all of the services into the Google Cloud Platform so that they could get all of the good stuff from Firebase and push Firebase users to Google's offerings for the things that were perhaps subpar in the Firebase platform. That being said, it was kind of surprising to see that over the years, Firebase has actually expanded. There are so many different services that Firebase offers today. And that's why I like to call Firebase Google Cloud's evil twin. Because Google has it in their attic, they've locked that service away. They're feeding it enough table scraps for the programs to still remain today. But every so often, the evil twin gets out of the attic and it can hurt people very seriously, unfortunately. So while I'm not here to tell you that all of Firebase has problems, I am going to talk about the Firebase databases and the problems associated with them. Because the rest of the platform, for all I know, might be completely acceptable to use. I cannot say that I've used every one of these services. They come up with new services all the time. But I will talk to you about the concerns that I have regarding the real-time databases. They actually have two different types of databases that are real-time. The original real-time database and the Cloud Firestore. The Cloud Firestore is basically the real-time database, but much faster, much more structured. A real-time database is just JSON data, whereas Cloud Firestore has their data segmented into collections. So you're able to make queries on the Cloud Firestore a lot more efficient. That being said, they're not getting rid of the original real-time database. They say that this is because there are use cases for different types of databases in their platform. I think it's largely because if they got rid of the real-time database, it would break a tremendous amount of the internet. And they don't want to be the cause of an availability crisis either. So the core issue with the Firebase databases is what is called the hospital gown vulnerability. This is a term that was put out by a security research firm that no longer exists. They're called AppThority. They were acquired by Symantec, which was then acquired by Broadcom. And as far as I can tell, they no longer exist. But in 2018, they created a report on this issue and they called it the hospital gown vulnerability. Now, this report was really funny, for a lack of better words. They used a lot of really interesting and colorful and memorable language because they called the issue the hospital gown vulnerability. What is the purpose of a hospital gown? Like, really, what is the purpose of a real world hospital gown? Well, it covers your front end, but it leaves your back end wide open. That's literally why they named this vulnerability the way that they did. Applications with the hospital gown vulnerability look like they are secure from the front end, where the application may filter out data that doesn't belong to you and won't allow you to access data that doesn't belong to you. But if you go directly to the database is world readable and world writable. I also want to mention that this is not technically a vulnerability. It's a misconfiguration. This is not something that Firebase can fix unilaterally. They might be able to push their users to use better configurations, but this is not something that Firebase can just hot patch. So I just want to be clear, it's not really a vulnerability, but it is something that causes a lot of problems in a lot of applications. According to their reporting, applications on the Android marketplace that were vulnerable were downloaded over 650 million times. They said that 62% of enterprises were affected, although I'm not really sure how they calculated that. And they said that more than 100 million records were exposed. I'm also not really sure what to make of that because in the Firebase real-time database, at least, there's really no concept of a record. The databases are just JSON blobs. So I'm not really sure what they counted as a record, but I have no doubt that a tremendous amount of data was compromised. Now, in the case of T, at least according to Business Insider, they interviewed one of the security researchers that were involved with the breach. I don't know if they were one of the perpetrators or if they were just doing additional research. I genuinely don't know, so I'm just going to say the security researcher. They said that, frankly, T did a lot of really good security stuff on the code they wrote themselves. That's what he said to the article. He also said that the API was, quote, very secure. However, he stated that the problem was that T used Firebase to store its data. And T did not do the same kind of security work on the Firebase database as they did on their application proper. Based on just some of the terminology that I've seen in these articles, I believe that this was the real-time database, although it could have been the Cloud Firestore, and similar issues could have occurred with that as well. Now, the reason why I really wanted to talk about this today is because I've been on this soapbox for nearly 5 years now. Outside of the App Authority report that I cited earlier, there hasn't been a whole lot of articles on the subject. I published one as a result of this in late 2020. And then every once in a while, I would see some reputable security firms talk about these issues, with Avast Security Labs having a report in 2021 and Checkpoint Security also talking about this in 2022. And it doesn't seem like many people paid attention to those reports. However, outside of T, one of the largest, most high-profile breaches was one that was reported by some security researchers on env.fail, where they actually were able to prove that 900 sites were vulnerable to this issue. And they demonstrated this with some real exploitation, something that I would not have done for my research. And let's just say that these people, I'm sure they're very smart. I wouldn't call them the most sophisticated group of security researchers in the entire world. The lead security researcher's name was Mr. Bruh, and he had a Team Fortress 2 profile picture. One of the other people has like a chibi anime profile picture. I don't. These weren't. These were not professors, let's just say. Very smart though, and were able to tear these websites apart. And what's worse yet for me is that I've taught hundreds of SAN students in my course Sec 510, Cloud Security Controls and Mitigations. And we have an entire module on Firebase, and I'm going to demonstrate what our lab looks like for Firebase at the end of this presentation. But every time that I do this course, every time I teach it, less than 1% have even heard of Firebase. I've had one instance in which I asked them, have you heard of Firebase? And one person raised their hand, and I asked them, where did they hear about it? And they said, I heard about it by reading the Sec 510 syllabus. And I'm like, that doesn't really count. Have you heard of it outside of the Sec 510 syllabus? And they said, no. So that's really unfortunate because this is a very serious problem. And a lot of people, when I talk about this, they think maybe Brandon's exaggerating a little bit. Maybe these are issues that require a lot of knowledge about security in order to break in. Well, I'll leave you to be the judge of that. Here's how to download the entirety of a real-time database that is publicly accessible, that has the hospital gown vulnerability. Are you ready? You have to know the name of the database and plug it into your browser or download it using curl. That's it. If the database is misconfigured, it'll just give you all of the data. You could do this with just a browser if you'd like. But I mentioned it's not just about read-only access, it's also about write access. Certainly overwriting the database must be quite difficult. Well, yeah, you have to add an HTTP method to say I want to put the data instead of getting the data. And I also have to provide the data I want to overwrite the database with. But that's it. Oh, did I mention that Firebase's real-time database does not have versioning on it? I don't even think it's possible to turn on versioning. I think you have to back it up yourself. So with this one command, I could just wipe out your entire database and possibly destroy your application, and you wouldn't be able to recover from that. So this is not just about confidentiality, it's also about integrity and availability. This issue also exists for the Firestore, although it requires you to run some additional tools. There's a web interface that you can use called the Firestore Explorer. And if you find the name of the database and the name of the collection that you want to extract the data from, you're good to go. All you have to do is get some data out of the application itself, which is publicly exposed, and then you're off to the races. Overwriting the database is also quite easy. All you need is some JavaScript code, though. A little bit harder than working with the browser, but you could probably get ChatGPT to write this exploit for you. You can probably vibe code out the exploit. Now, why does this happen? Well, a large part of this has to do with this thing called test mode. When you set up a database in Firebase, you have the option for both types of databases for either using production mode or test mode. And if you use test mode, it's going to make your database world readable and world writable for the next 30 days. As you can imagine, that's quite dangerous because in that time period, there's just zero security whatsoever on the system. Now, you will get a notification like this that says, hey, your access to the Firestore or the real-time database is going to expire in 1 day. I've gotten this email before. And I want you to really put yourself in the shoes of a developer that receives this email. Perhaps it was forwarded to them from their manager. Let's imagine for a second it's the weekend, perhaps it's even a holiday. If they get this message, what are they going to do? Are they going to leave their activities? Are they going to leave the party that they're at, go home, open up their computer, re-architect their application to either not use Firebase or to use Firebase in a secure manner? Are they going to put this change into code review? Are they going to get all these other people to review their change? Are they going to put it through the CI/CD pipeline and change control and then fix the issue within 24 hours? Or are they just going to kick the can down the road and extend test mode another 30 days? I think that it's important to recognize that 90% of the audience here, myself included, would pick option 2. Not just because of the security concern, and not just because that would require me to go away from my weekend activities, but it could also result in the application crashing or being destroyed in the first place. You know, if you're deploying something very quickly to fix this issue, who knows that you're not introducing new issues in the process? In Firebase's credit, you also get some alerts letting you know that your database is wide open, but if you don't have an incentive to fix it, why would you? Now, test mode has only existed for about 6 years. I don't know when they've introduced test mode. I know it wasn't around in early 2019, and I know that it was around in late 2020. So I think it was somewhere in the late 2019, early 2020 time period. Before test mode was introduced, there were actually another set of rules that were turned on by default without notifying the user. And what this rule set says is that anybody who's authenticated could access the database and write the database without any proof of who exactly they are. This can actually be extended. You can actually make the database world readable and world writable indefinitely, which is something that a lot of people did. And in fact, a lot of Stack Overflow posts recommended that people did that. which is another example of how we should not trust strangers on the internet. We also shouldn't trust AI systems on the internet. So while it is possible to secure Firebase databases, they make broken authentication and authorization far too easy. There was a person who claimed to have worked for Firebase for many years, and he said that security rules have plagued the product. Quote, "We tried a lot of approaches, such as self-expiring default rules, more education, etc. But at the end of the day, we still see a lot of insecure databases." End quote. And you can find the full thread on Y Combinator. They talk about some of the details about why they could not fix this issue as well. There's a lot of good reasons why this is just a difficult thing for Firebase to put together. But I'm not saying that the Firebase real-time database is inherently insecure. I'm saying that it's really easy to be made insecure, at least until I get to this slide, because here's where I tell you that the real-time database is somewhat inherently insecure, at least from a reconnaissance perspective. Detecting where your database lives and finding if a database exists is trivial. All you need to know is the name of the database, and you plug it into your browser, and it's either there or it's not there. There's a different structure of the URLs for European and Asian databases, but because Europe and Asia was only introduced for the real-time database in 2021, the vast majority of databases are in the US. So you don't even have to really try all three of these patterns. You really only have to brute force database name.firebase.io.com. Funnily enough, at one point, these subdomains were exposed by DNS-A records. Someone would say, "Hey, firebase.io.com, what subdomains do you have?" And DNS would say, "Here are all my subdomains," meaning here are all of my databases. And many of these are still cached. Now, many of these databases have been indexed by search engines as well. If you go to a search engine of your choice and you type in site:/firebase.io.com, you're going to see a lot of publicly exposed databases. This is a lot harder to do on Google. I found that a lot of these records have been purged, at least temporarily they were purged, but they're available on other search engines, which is kind of curious. You know, Google owns Firebase, Google owns Google Search. Perhaps they were trying to make it so that their databases were harder to access. But when all else fails, databases can be enumerated. If you find a database that is real but has some kind of authorization required, it'll say permission denied. Whereas if you find one that doesn't exist, it'll say 404 not found. This can be very frustrating to you, even if you don't use Firebase, because I worked with an organization that had a situation where someone reported that their database was wide open. The name of the database was company name-db.firebase.io.com. And the organization went scrambling, trying to find who owned this database so that they could decommission it. Turns out that database was not owned by that company at all, and it just happened to have that name, which is, you know, something that was very frustrating to say the least. So we have different types of Firebase security rules, and these are all proprietary security rules. These are not generally used rules that you can use on multiple platforms. This one says, as long as you're authenticated, as long as your auth ID is not null, you can get into the database. So we made a better rule set for our lab environment that says, hey, if you want to access a chat session, you can only access chat sessions that are named after your user ID. So you can access your session, but not other people's sessions. So that's a huge improvement, but you'll see in a moment our chat platform, there's no good reason for our chat platform to allow for people to delete or update messages either. So if we wanted to make these chats writable once and readable indefinitely, we would have to add another rule that says you're not allowed to write data unless the data does not already exist. And this is showing you the real-time database equivalent and the Firestore equivalent. Now, you can lock down these database rules very well. I have had assessments where I found applications that were locked down fantastically using the Firebase security rule set. But one of the risks associated with that, honestly, is how many people in the world know how to set these up. I may have encountered the Firebase rule set wizard, but if that person left the organization, how maintainable would this be? I don't know. I think the answer would be not very maintainable at all. Now, there are also some implications for Google Cloud and compliance. We talk about this much more in Sec 510, but in summary, when you set up Firebase, you're normally going to associate it with a Google Cloud project. And if you delete Firebase, it will delete Google Cloud's data as well. That's what this last warning says here. So if you're using Google Cloud and you have Firebase attached, you better make sure that no one's able to delete that database. And secondly, permissions are shared between the two of them, and this could result in some serious privilege escalation in Google Cloud. In fact, there is an organization policy that is critical for reducing the likelihood of privilege escalation in Google Cloud, which is called IAM.disable service account creation. And while this is a great policy to use, it is unclear whether or not Firebase would continue to work if you implemented this policy. So that is a very serious risk as well. It can result in your application no longer operating properly. And there are some compliance concerns. Firebase authentication processes data exclusively within the United States, and they only recently added the real-time database and hosting to the list of platforms that can be hosted internationally. And all the other services are considered global, which means based on my read of the terms of service, I'm not a compliance person, I'm not a lawyer, but based on my read and several other people's read of their terms of service, it states that they could process your data anywhere, including all of Google Cloud's data centers, which include about 50 distinct regions. So while this is great for high availability, it can also be a nightmare if you have to deal with certain compliance regimes. Now I'm going to demonstrate how Firebase can be exploited with a real application and a real-world demonstration. Here we have the application that we use in the Sec 510 lab environment. This is for a fictional company called Nimbus Immutabile, and they are a healthcare provider. And here, Nimbus and their chat team is asking, how can we help you? There's a lot of these chat bubbles that pop up all the time on modern applications where people will say, hey, you're on our webpage, you probably need some help. How can we help you? And people will start to, message them. This makes it really easy for people to interact with these companies because it has no friction. You could see that I'm not logged into the platform and I'm still able to talk to this chat representative. And I'm going to say, I need help with my claim. Now, that's going to result in a message saying, one moment, please. This chat is not monitored, so it's going to just hang here indefinitely. But if we go to the database itself and we look at the data, we can see that I have this chat session, which is labeled 90ZW. And in here, I have these different messages. Welcome to Nimbus Immutabile. I need help with my claim. One moment, please. And if I replace this with T breach webcast and I hit enter, you'll notice that the UI updates immediately. It's just that simple. The database is synchronized with the user interface, and the user interface is synchronized with the database. Unfortunately, if we look at our rule set, we can see that the database is wide open. Anybody can read the data, anybody can write the data. So while I'm only able to see my session here, I could theoretically see the entire database by going directly to the database. I can do this by inspecting the network traffic. And if I search for firebaseio.com, and I refresh the page, I will see this request or this request over here that's going to have this namespace, ns equals cwdev, and then the string over here. That's the name of the database. And if I go into here and I type in the name of the database, firebase.io.com/.json, we could see the entire database without any additional authentication whatsoever. I'm also going to demonstrate this in the terminal for reasons that will be clear momentarily. Here we have our SANS Cloud Security Flight Simulator, and we use this to interact with our remote server that our lab environment uses without any virtualization on our end whatsoever. You can do the Sec510 labs with whatever machine you want. We've tested it out on a 2011 MacBook Air, and it worked fine. All you need is a Firefox browser and the ability to install this plugin called Smart Proxy. Well, anyway, I'm going to export the name of this database as Firebase DB. And I am also going to export the name of this session. So the session here is that one that starts with 90Z. I'm going to export session ID is equal to this. And now, with a relatively simple command, I can also hijack this session. I can add a message that says, happy to help. Before we get started, can you provide your name and social security number? And now we will see this message from the chat agent that says, happy to help. Before we get started, can you provide your name and social security number? Now, because this user trusts the company, Nimbus Immutabile, they're going to potentially disclose their information. Sure, my social is 702, just kidding. One of these days, I'm going to disclose my social security number accidentally in one of these demonstrations, and then I'm going to have a miserable day, possibly a miserable week. But until then, I'm going to keep playing with fire, no pun intended, and continue to do this demonstration. So how do we lock this down? Well, we're going to apply a better set of rules. I'm going to check out a better set of rules from our code base, and I'm going to deploy that rule set. And what this rule set is going to do once it deploys is it's going to do exactly what the original default settings would do. And that is going to allow you to read and write the database, but only if you're authenticated. So if you're not authenticated, the database is going to say permission denied. However, authentication is pretty trivial. In fact, in the case of our application, we're actually using something called the anonymous provider to allow people to log in with a unique identity simply by accessing the page. So I'm going to look for that traffic where we authenticate, which is get account info. I'm going to refresh the page. I'm going to look at the token in the request, this identity token. This is a JSON web token, which we can decode by going to jwt.io. And you can see that this token is an anonymous token for this project. The user ID is 90ZW, which is the name of the session. And now if we export this ID token, we could actually just do this in the browser. If I just add auth equals this, it'll give me the entire database once again. So we have to get better than that. We have to get a rule set that actually enforces role-based access control. So I'm going to deploy another set of rules. And this rule set is going to say that you can only access the chat session associated with your currently logged in user. I'm going to refresh the page here, and we're going to see the rules that I showed in the slides, where we are going to allow you to access a chat session, but only if the chat session is for your user ID and only if your user ID matches the name of the chat session. So we can access the 90ZW session, but if we try to access the entire database or someone else's session, it's going to give you a permission denied error. Now, there are so many other rules that you can apply in Firebase. It's very complicated. And frankly, there's a whole lot more to it that I simply don't know, even though this is a subject that I've researched extensively. So at the end of the day, Firebase is a product that if you're not able to support, it may not be one that you want to use, at least not the databases. But I like to use the phrase, if you're camping and you see a bear, you don't have to outrun the bear. You just need to be able to outrun your campmate so that when the bear catches your campmate, they'll be distracted by them and you'll get away safely. Now, you don't want your campmate to get mauled by a bear, absolutely. But, we need to make sure that we're at least as secure, if not more secure, than our peers. And trust me when I tell you, very few people that are using Firebase are even trying to lock down this database. And so perhaps you would still be vulnerable to advanced persistent threats if you applied the rule set that we just showed you. But hey, perhaps you would not be compromised by a security researcher with the alias Mr. Bra if you implemented the rules shown here. And now I'm going to leave you with some additional resources. If you'd like to learn more about Firebase, definitely check out that white paper that I mentioned earlier, which you can find at sec510.com/firebase-paper. Now, this paper is 5 years old, but unfortunately, nothing's really changed about the landscape of Firebase. In fact, you could argue that it's gotten worse because there are all these new services that we haven't had enough time to vet. You could also take a look at our secure service configuration poster, which is at sec510.com/poster. Will help you prevent issues like this one, but in different platforms. You can take a look at our Terraform poster, which was released recently at sec510.com/terraform-poster. Terraform is a great way of codifying some of these configurations in an automated fashion. We also have a cheat sheet that will help you create multi-cloud commands that will help you secure your environment. And please take a look at sec510.com/demo. This is the best kept secret at SANS, is that we allow people to take a basically free hour of material from all of our courses, and not just any individual course. You can take a demonstration of every course and get like 80 hours of free content. So please take advantage of that. Take a look at sec510.com/demo to see a real lecture that I've given in the course. And also make sure to check out sans.org/cloud, which has all of our resources on cloud security. I also have to briefly plug Sec510 Cloud Security Controls and Mitigations. We have a couple upcoming sessions, one in Boston that's going to be taught by the amazing Simon Vernon in August 11th through 15th. You can also attend it virtually from 9 to 5 EST. We also have an event in Las Vegas that I'm going to be teaching from 9 to 5 PST or in person. And you can also take the class on demand anytime, anywhere with me as well. I've had the honor of getting a lot of great reviews. I share them with you here today. One of the ones that I'm most proud of is the one that says, "If you cloud, you need this course, period." And I hope that emphasizes the importance and value of what Eric Johnson, my co-author, and I have put together. Once again, thank you so much for listening to what I had to say. You can find me on LinkedIn at Brandon Evans. You could also check out my email and send emails to me at bevans@sans.org.